Magic Leap. Today we want to be going over some very practical examples that you as creators can start to take away and integrate into your applications right away. We also want to cover some more advanced topics so that you can fully take advantage of Magic Leap in this new spatial computing platform. Now, we have a lot of stuff to cover, and there's going to be everything from visuals to code snippets, so I strongly encourage you guys to maybe move a little bit more forward, but rest assured that we're going to be releasing a video as well as the slide deck at a future date. My name is Dan Miller.
Hi, I'm Unity3D.
All right, so let's go ahead and get started. As an outline, we're first going to be talking about some recommended settings, why some of the settings are the way they are, so that you can get a broader understanding of the platform in general. Next, we'll be talking about the Drive application and how we've modified it to use the navigation system built into Unity, as well as some key takeaways that they did really well on that project that you can start using as well. After that, we'll talk about persistence, which allows you to bring back content between application loads and really extend your current applications. And finally, we'll be taking a brief look into the future of Magic Leap as well as Unity. So let's go ahead and get started.
Thanks, Dan. So in the next few slides, I'm going to walk over some of the important settings that you need to consider when you're starting a project with Magic Leap. And I'm also going to discuss some of the recommended values for these settings. So let's get started. First, let's look at the camera settings. Make sure that the transform on the camera is set to identity. If you have any position or orientation offsets on your camera, it will get added to the head position at runtime. And that can result in some unexpected translation and rotation of your content. Similarly, if you don't have an identity scale set on the camera, that can result in some unexpected scaling effects. So make sure you set the camera transform to identity. We'll talk about scale in general in the future slides, but for now, let's move on to the next setting. Make sure the clear color for the camera is set to black. Magic Leap is an additive display, so black is rendered as transparent. So by clearing the frame buffer to black, everything around the content gets transparent. We also recommend that you set the alpha value of this black color to 0. By setting the alpha to 0, we can leverage the dirty tile mapping optimization by only looking at the non-black, non-transparent pixels that got modified in the frame buffer. The near clipping plane on Magic Leap device is enforced at 37 centimeters, which means any content that's rendered in that range gets clipped out. Now, based on the experience you're trying to build, this can be a bit limiting. So we recommend that you either fade the content out or push it back as the user gets closer. And you can see this in action in our Go sample available at the developer. Far clipping plane is recommended to be set very close to the content. The reason is far clipping plane is used as a reprojection plane during the time warp. Now, time warp is the process that we use for correcting the projected image to account for the tiny head movements between the update and the render. If you set the far clipping plane too far, you can see the content shake as you move sideways. We also call it judder. So to reduce the effects of judder, make sure the far clipping plane is as close to the content as possible. Now, if you're interested in knowing more details about reprojection planes or time warp, we are covering that in more detail in the 3D game engine integrations talk later today. The stereo separation value, also known as the interpupillary distance, gets overwritten at runtime by the eye calibration data. The stereo convergence distance is used for calculating the focus distance. The focus distance on our platform is used for selecting which depth plane is used for rendering. One thing I want to point out here is by default, we use the eye calibration data to decide which depth plane is used for rendering. But if that fails for some reason, we use the app supplied value of stereo convergence distance here. And stereo convergence point is just a convenient way of calculating the focus distance by setting the game object that the user might be focusing on. Now, starting with Qualified Developer Release Update 2, we are introducing a new value called Stabilization Depth. As I mentioned earlier, far clipping plane is used as the reprojection plane. But if you have an app where content is getting added and removed constantly, then adjusting the far clipping plane close to the content can be a bit tricky, and it can also result in some undesired clipping effects. So in that case, instead of using the far clipping plane, you can use stabilization depth. The stabilization mode is used to calculate the stabilization depth, and there are three values. By default, it's set to far clipping plane, but you can also set it to the farthest object, in which case the engine automatically calculates the farthest object in your current view frustum and sets the stabilization depth to that point. Now, if you use the custom distance, then make sure that the stabilization depth is between the focus distance and the far clipping plane as shown in this picture. As you saw, there's a handful of settings you need to do on the camera. And every time you create a new scene or create a new camera, setting that those values manually can be a bit tedious. So we have provided a Magic Leap camera preset that you can use. Now, the right way to use this preset is creating a game object in your scene hierarchy. Make sure it's transformed with reset to identity, and then drag the Magic Leap camera preset onto that. Also, make sure that when you create a camera using the preset, it's tagged as the main camera. Let's talk about content scale a little bit. Content scale is very important in spatial computing because you're rendering virtual objects in proportion to the real world objects. So for example, in this case, I have a chessboard which can be either too big or it can be too small for the ottoman I'm trying to put it on. So in order to get it just right, I can either scale my content down or up. Now, as you might be aware, that this may not work in all scenarios. For example, physics, particle effects, terrain, Navmesh, they don't scale very well with the content. So in those scenarios, instead of scaling the content to work in the device scale, which is in meters, we do the opposite. For example, in this picture, I have a butterfly which is modeled in centimeters. So one scene unit is 1 centimeters. Now, instead of scaling my butterfly in meters, I'm going to scale the head position reported by the camera to the centimeters. Now, you might be tempted to set the scale directly on the camera, but like I said before, that can cause some undesired scaling effects. The right way to do that is to create a game object and make it a parent of your camera and set the scale on the parent of the camera. Like in this picture, I have set the scale on the parent of the camera to 100 because I'm trying to convert the head position reported in meters to centimeters. Similarly, if you are not using the standard 1 meter scale and you're using ML Spatial Mapper, make sure that the parent field in the ML Spatial Mapper is set to the parent of the main camera. Near far clipping planes, stereo convergence distance, stabilization distance, they all need to be specified in the scene units as well. The underlying color space used by our graphics layer is linear, so make sure you set the color space to linear. Also, the color banding is less prominent in the linear color space, and the lighting calculations are also more accurate on the color space. To improve content stabilization, in addition to setting the far clipping plane and the stabilization depth, we also recommend that you maintain a frame rate of 60 or above. Also make sure that your frame rate is steady. If your app can hit frame rates above 60 frames per second, but cannot maintain a steady frame rate, then you can set the frame rate to 60, which will cap your frame rate to 60 Hz. And by capping the frame rate to 60, we are essentially ensuring a constant 16 millisecond cadence per frame. which improves this, the time prediction and the head pose prediction during the time warp, and thereby improves your content stabilization. If your app is simple and can hit frame rates above 120, you can set the frame hint to 120. Although for the most part, 60 would be sufficient. If you set the frame hint to unspecified, then we don't cap the frame rate, in which case you can use that information for debugging the frame rate variations. Certain features on MagicLeap device require you to request user privileges. We expose the user privileges in the form of checkboxes under published settings. There are three kinds of privileges: non-sensitive, sensitive, and reality. Non-sensitive privileges require you to just check the right checkbox under published settings, and it adds a line to the manifest for your project. Sensitive privileges require one additional step where you have to request the privilege from the consent from the user at runtime. And reality privilege require one additional step where you have to request the privilege every time the app resumes. This is because the user can go to the settings and revoke the permissions to your app.
I feel like this is why my apps never work the first time.
Yeah, actually this has been one of the most common problems developers have reported. So we are trying to increase the awareness around this by adding more documentation to our developer portal and also talking about it in these session talks. We want you to be focusing on creating content and not requesting privileges. So we have added a privilege requester component that in the Unity package that you can use. All you have to do is just drag the privilege requester onto the game object and configure it with the list of privileges you want to request. Then in your app, all you do is listen for on privileges then check for the result, and if the result is okay, which means the user gave you the permissions, you can go ahead and use the feature. MagicLeap is a growing platform, and we are constantly adding new features. And as developers, you want to use these features. However, you also want to make sure that the feature is actually available on the operating system your app is running on. In short, you want to make sure that your app is backwards compatible. So in order to facilitate that, we have added a field called platform level that you can check at runtime and check and gracefully handle the lack of feature on the operating system you might be running on. But at some point, your code's gonna get messy with all these platform checks, and you might want to just target a minimum platform API level. And you can do that easily by just setting the minimum platform API level in the player settings. All right, so I hope that gave you a good overview of the various settings, and we also talked about backwards compatibility. Now let's hear from Dan about how we modified the Drive project.
Great, thanks a lot. So, as you guys might be aware, the Drive project is a sample on the Creator platform, and it features 3 different vehicles where you can kind of fly around and move throughout the environment. And so what we did is we're focusing specifically on the buggy or the car and modifying it to use a navigation system within Unity. And what we want to accomplish, and what we did accomplish, was the ability to move the car around, and as the environment updates and becomes dynamic, avoid obstacles. So to start off, we just want to show a small video of how this works. So the first thing we're doing is going into the garage here. Navmesh will be talking a little bit about that functionality later. But after that, you might notice that somebody throws a pillow in the environment. One of the most dangerous obstacles for any toy or remote car. And after it comes out of the garage, we're able to form this navigation path specifically around the pillow. And that's because we're taking advantage of the Magic Leap, using this as a spatial computing platform, and understanding this world reconstruction and the environment which the app is running in. So now let's take a little bit of a look at how we can accomplish this through the settings within Unity, as well as some code. And first, I need to talk about Nav Mesh Components. If you're familiar with the navigation system within Unity, you know that by default, it's configured for offline baking. This is pulling in something like a terrain or 3D geometry, setting it up, and then baking where your navigation mesh agents can actually go upon it. But as we saw here, we need to be able to do this at runtime. So how do we solve that problem? We're using something called Nav Mesh Components, which is a system built by Unity that is built on top of the navigation system and is currently separate outside of Unity. And the reason we need to use this is because we want to be baking these at runtime. We want to take advantage of this world reconstruction and this dynamic environment. And if you guys want to get the Nav Mesh components, they're freely available on the GitHub link there through Unity's official GitHub page. But first, I want to talk a little bit about the question that everybody asks, and that is when to bake. And the reality is that there's really no simple answer to this, and it can be really dependent on your application. If you wanted to avoid obstacles like we have here, then it makes sense to link into the spatial mapper and continually update this as the environment changes. If you want to create maybe something where your whole experience or environment is contained within a specific room, then it might make sense to bake it after doing a little bit of a calibration step. So talking about the Nav Mesh components and how these link into Unity and how you can take advantage of this at runtime. The first part of this is the Nav Mesh surface, which is a new additional component here that you put on an object in the scene. Now the thing to make note of here is that the Nav Mesh surface, each specific component is set up with each specific agent. So I've configured the agent type here to be the buggy, which is representative of the car. From here, I've gone in the normal built-in navigation system within Unity and adjusted this buggy settings to be relative to the size of the actual car. And while Abhijit mentioned earlier, you have to be a little bit careful about how and when you're scaling your content, it was okay for us to scale down the buggy, and you can see that the settings here for its size and radius are relative to the actual size in centimeters. Now the last thing I want to mention with the Nav Mesh surface that you can configure is this override tile size. And by default, this is set to 256 and works well for bigger, maybe humanoid environments. And so we've lowered this a little bit just to get the cutting a little bit more accurate so that we can take into account things like smaller obstacles, like those dangerous pillows we saw earlier. So once you've set this up in the scene, now we're going to take a little bit of a look at how to link into this at runtime through some code. So the first thing you need to do is just get a reference to that Nav Mesh surface and call the build Nav Mesh. Now, because we're using the ML spatial mapper, what we're doing here in the await function is linking into these events that are called when the spatial mapper is added, updated, or removed, and then calling a simple function there that'll then link in and queue up our rebaking process. Now for updating or rebaking the Nav Mesh, we're simply checking a bool here that gets flipped through those events, and then we're going in here, taking the Nav Mesh surface and calling update Nav Mesh to take advantage of that new spatial mesh that's been created from the Magic Leap. Now, this can be a little bit difficult to really understand what's going on, and so one of the debugging steps that we took was to actually recreate the mesh created by the navigation mesh, and then just create a dynamic mesh at runtime so that we can visualize it within the application itself. Usually navigation meshes are only visible within Unity when you're not running the scene or when you're checking it out in the scene view. Now I just want to talk a little bit about scanning and baking. So our application obviously needed to bake at runtime so we can avoid those obstacles, but there's also some compelling arguments for when you would want to scan then bake. And the reality is that this is going to be preferred for performance because you're not updating that navigation mesh as often, and you might only be doing it once. The other thing to really consider here is think about the volume size or the room that you want your user to be interacting with. Do you want your content to live on a coffee table, or do you want someone really moving around the bedrooms or something like that? And you can actually kind of specify this with your spatial mapper of how far and how big you're creating it. And last but not least, think about guiding your user around. If you've ever experienced something like the Create application, you know that they have very direct kind of targets that you look at as you kind of build up the spatial mapper to really understand your environment. On the opposite side, we have something like Tonande, which actually draws you into the environment with interesting visuals and sounds, and as you follow creatures around, you're building up that navigation mesh or the spatial mesh in the background without even really realizing it. So when the application needs to take advantage of it, it's already been built and understands the environment. And similarly, if you're using these navigation meshes components to build this at least once at runtime, you need to link it to that Nav Mesh surface and call the build mesh there. And here you can see this is just a little way where we're actually looking at what's happening in Unity using the 0 iteration and the ML remote.
Actually, I would like to share a quick experience I had. So when I was trying to debug an issue here, as you can see, the garage door is not closing. And I was at home, I didn't have a device with me. So I quickly fired up the simulator, loaded my project in it, and I was able to adjust the size of the collider, which was causing this issue. Imagine if I had to do all those little tweaks and do build and run every time I made a tweak. With the simulator, I could quickly iterate on it, and it was a huge time save. So if you guys haven't tried it, I really strongly recommend using the ML remote and ZI.
There's also a talk later today that goes a little bit more into this tooling, so you can fully take advantage of it. And the last thing I just wanted to describe with this modification here is how we're actually placing the car in the environment here. So for a combination, we're first starting off using the controller input and the controller raycaster script, which are just built in there with the MagicLeap Unity package. And you'll notice something with the controller raycast that we're actually looking specifically for the dense reconstruction layer. And this has been set up beforehand to be aligned with the actual spatial mapper. Now the last thing we have here at the bottom is just a simple script using a line renderer to visualize the line coming out of the controller to know if it's a clickable space or it's an obstacle. And I know whenever I'm kind of diving into a new project and trying to understand how it's all put together, it's really helpful to kind of understand where some of these things are set up. And so the dense reconstruction is actually the original object underneath the spatial mapper, and you can see that it's configured for the layer there. And this just has an empty mesh filter, collider, and renderer that gets propagated at runtime from the MagicLeap APIs. So now I want to talk about a few things that Drive did that really help your application stand out and create a better overall experience. Now, I see this a lot, especially on Twitter videos and things like that, where I'm seeing a lot of people create some really good content. And one thing that I want to talk about now is just the lighting and shading models that you need to consider when building for these additive displays. So by default, you can see in this video that the lighting model has a light coming down from the top, and on the standard shader within Unity, it creates a light pattern on the top where the light is, and then it fades out to a black or a gray, and this creates transparency because we're building on an additive display. Now, this is naturally how lighting works, and this is how the standard setup works, but more often than not, we want our objects to really feel like they're in the world. We want objects that are meant to be opaque, to block real-world environments as well as digital, and not really appear transparent, unless we're doing something like glass or another type of material. So what Drive did for this is they're using a BRDF shader, which actually kind of does the opposite. And you can see visualizations in the setup here in the yellow orb, as well as the white one. So instead of taking the lighting model and being light on top and then fading out to a darkness, it maintains the entire light throughout to maintain that opaqueness, and then kind of does the opposite by adding a highlight to the top of the model. So you can still get this effect where it looks like it's being shaded or lightened, but you can maintain these really opaque models that actually exist in your environment. And you can see here there's also things like a cube map where you can actually specify where the lighting is coming from for that highlight, as well as things like a ramp map, so you can kind of more finely tweak some of the visuals that you're having there. So I strongly encourage everyone to check out these shaders and start integrating them into their objects. Next thing I want to talk about is Drive has a lot of really nice utilities and helpers already included within the project. On the left here, I have a simple trail renderer that's following my hand as I move it around, and you'll notice that things get a little bit jaggy. As we move around, there's kind of a little bit of edges as it's trying to catch up to my hand. And this is me just simply parenting the object underneath the hand tracking. On the right, I'm using one of these utility scripts here called Tether, and what it does is it gives you a dead zone as well as a transform to follow. And the end result here gives you a much smoother experience with this trail and something that just looks and feels a lot cleaner. There's also included helpers and utilities for things like tweening as well as placement as well. The next thing I want to talk about is headlocked content. In a lot of your applications and experiences, you have instructions that you need the user to read or understand in order to get started. Whether this is just an introductory text or some key instructions for them to fully understand. And it might be an easy idea to just simply put it in front of the user so that everywhere they look, it's locked to their head. But the reality is that this can feel a little bit uncomfortable. So what we're doing here is we're using the head pose canvas script and creating a UI canvas that's actually rendering in world space. If you're familiar with UI in Unity, you know that there's world space and screen space. And world space allows you to really place it positionally within the environment or the world. This head pose canvas script allows you to specify the distance, how far away your canvas is, as well as the speed and rotation at which it catches up with your head. And you can see as I'm looking around here in my apartment that while I'm able to avoid the content, it still always catches up and allows me to read what's on it. The next thing I want to briefly mention is shadows. Now, as we've talked about before, this is an additive display, so normal shadow colors like blacks or grays are just going to appear completely transparent. So what I've done here is a pretty simple technique for a blob shadow or a drop shadow, where we just create a sprite that's a similar shape and size to the object itself and put it underneath it. I strongly encourage you to think about what your application and your experience is. If it's something like science fiction, you might go with some purples and blues. But one thing to keep in mind, this was something I kind of discovered along the way, is you have to really consider where your content is going. Here we have a similar thing, and the shadow is meant to be blue, but it's actually on a red nightstand that I have, and so it actually ends up appearing a little bit purple. Now, I don't know how many people have red nightstands, but something to think about there. Now, the next thing that I think is really awesome about Drive, and this is something that I've seen a lot of really magical experiences and moments, especially on Twitter, when you see particles actually interacting in the real world and in your environment. Whether you're crashing into a wall and it's bouncing off your nightstand, or you're crashing into your buddy's head and it's bouncing down his shoulders, having particles that actually collide with the world is a really great way to just make your experience more immersive. In order to enable this in Unity, the first thing you need to do is enable the collision module within the particle system. After that, you can set its type to be world in 3D so that it takes advantage of everything in your environment, not just planes. And last but not least, something to consider is setting the collision quality to high, as well as the enabling dynamic colliders, so that you can take advantage of things like when your hand or your controller moves, if there's a collider associated with it. All right, so I've talked a little bit about the visuals and what you can do to really bring your project to the next level. And now I just want to briefly go over some things for sound. As we know with these immersive mediums, sound can be just as important to visuals to really put you in the experience and make it feel real. So in Unity, you first need to go to the Audio Manager under Project Settings, and to take advantage of the Magic Leap Spatialized Audio plugin, you can set it here in the Spatializer plugin. Now, if you've ever used Spatializer plugins in Unity in the past, you know that after you enable this within those settings, it gives you an additional checkbox on your audio sources, down here at the bottom for Spatialize, as well as Spatialize Post Effects. All audio sources have the ability to be configured in 3D, but if you don't spatialize them and you're not using a plugin, you'll hear sound out of a single ear, depending on where it is positionally. If it's over here, I'll be hearing it from my right ear. And with the Spatializer plugins, it actually creates sound in both ears, with one being more dominant than the other, depending on where it's at spatially. Now, once you've enabled the plugin, once you've configured the spatialization within your audio sources, you also need to add a couple more additional components. The first one is the MSA source to the game objects with your audio sources. And what this does is give you a little bit finer tuned control over the exact specifications and settings of your audio source to make them even more spatialized. And last but not least, you need to add the MSA listener to your audio listener, which more often than not is associated with your main camera. And just to give you guys a little bit of an example of how far you can take spatialized audio and what to really consider, I wanted to point this out here at the Drive project. And what they've done is they've actually added 4 different audio sources, one for each tire on the buggy or the car itself, and associated a sound with them. So that when the object is right next to you and as it moves around, each individual tire has its own audio source making its own sound, and together it really puts it and plants it there within your environment. All right, so that was a little bit about how you can take your project to the next level, some polish and some key takeaways that you as a creator can start integrating right away. And now let's hear a little bit about persistence.
Thanks, Daniel. All right, let's see how we can extend our Drive project by adding some persistence. So the goal here is very simple. I want to remember where I parked my car. I kind of struggle with that in my life too, actually. So as you saw earlier in the video, we pulled the car into the garage. Now what we want to do is remember or persist the position of both the garage and the car in our room. And we can do that using persistence. Persistence on Magic Leap platform is enabled through what is known as persistent ordinal frames, or PCFs. So what are PCFs? PCFs are arbitrary points in the space around you that the perception layer has identified. Every PCF has a unique ID, a position and orientation value that persists between device modes. At runtime, we associate your content with the closest PCF around it. By that, all we are doing is we are storing the position and the orientation offset of your content in something called as content binding. As you can see in this picture, the perception layer has identified a PCF on the corner of my table, and my content, which is the ball here, is associated with that PCF, and the little blue line is just a representation of the association in the two. One thing I want to point out here is the position where you start your device is not the same as PCFs and is going to change based on where you boot your device. All right, let's see how we can add persistence to our Drive project. Since I want to remember the position of the car or the buggy object here, I'm going to first start by adding the ML persistent point behavior. ML persistent point is the one that implements persistence in our Unity package. Let's look at some of the important properties of this behavior. The unique ID is used for identifying the association between the content and the PCF. Make sure that every object you want to persist has a unique ID associated. The timeout in seconds is the amount of time you wait looking for a PCF to associate your content. The number of retries for restore, as the name suggests, is used during the restoration of your content, and is the number of times we are going to try looking for a PCF that your content was previously associated with. And the retry delay in seconds is the amount of time that we wait between these retries. So pretty simple settings. Let's go ahead and add the ML persistent point behavior to the garage object and set the unique ID on that as well. One thing you might have noticed here is that the ML persistent point behavior is disabled by default. The reason is, as soon as it's enabled, it will try to either find the PCF or try to restore your object, and it will fail immediately because the persistence requires, it is a sensitive privilege, and you require user consent before using it. So let's see how we can add or request our privileges. First, we add the privilege requester component. Then we configure it with the PW font object read permission. The PW here stands for Passable World, which is the framework that enables the persistence. Make sure that the PW found object read checkbox is checked. And then I have added a drive privilege requester model behavior, which takes an array of persistent objects, which I'm going to configure with the garage and the buggy object. Then I listen for the onPrivileges done event, and based on the result, I finally enable the ML persistent point behavior. One thing to note about the ML persistent point behavior is once it creates the content binding and saves it out, if your object moves now, it's not going to auto-update the content binding. It's not going to recalculate the offsets automatically. This is because every time we update the content binding, we save it out to the disk. And if the object is moving every frame, saving it to the disk will be very inefficient and can cause hitches in your app. So we have provided another function called update binding that you can call only when you want to save the final position of your object. So in my project, in the RAD project, I want to save the content binding when the car enters the garage. So I've added a collider object, the floor of my garage. And I've written the enter garage trigger model behavior here, which first listens for the onComplete event, which basically indicates it's ready to update the content binding now. And then in the onTrigger enter callback, I first ensure that the object that's colliding with my collider is in fact the buggy object, and then finally update binding. Pretty simple. When the device restarts and when you reboot the app, the ML persistent point will try to restore your content automatically. And the restore binding function is the one that does it. The source code for the ML persistent point is available in the Unity package, so I strongly recommend looking at it to see how it works. All right, let's see this in action now. So this is where we pull the car into the garage. This is going to trigger the update binding call that I was talking about earlier. And at some later point, I rebooted the device and I'm restarting the app. One thing I want to point out here is, although I started the device in a different location, I'm in the same room. If you start the device in a different room, it won't be able to find the PCS because it doesn't know about it, and it won't be able to restore your content. I really hope that the car is back in its position. And voila, I found on the car. And so let's take it out of the garage and take it for a drive.
This is definitely one of the cooler features that I'm excited about.
Yeah, we are working on improving this feature in the future iterations. All right, so I hope that gave you a good overview of how to get persistence working in Unity. Let's look into the future for both Magic Leap and Unity. As I mentioned earlier, we are a growing platform. We are adding new APIs and bug fixes every release. These are some of the APIs that we are currently working on. We are also working on improving the zero iteration and the ML workflow by reducing some of the manual steps in that process. And as always, we are adding new examples to help you understand the existing and new APIs.
All right, and on the Unity side, our labs team is creating a new suite of tools and features built specifically for authoring for this new mixed reality and real world. And it's called Mars, and you'll see additional content and things like that coming out throughout the rest of the year and into next year. We're also working on what we call the IL2 CPP managed debugger support, and this allows you to go in and actually set breakpoints within your code. Really get that fine-tuned level of granularity that you want with debugging, rather than just littering your code with debug logs and things like that, so you can really understand the paths and where things are going. Next, we're introducing lightweight render pipeline support for Magic Leap, which, besides unlocking some key optimizations and features for modern platforms, it also gives you the availability to use things like the shader graph which is a node-based editor that allows you to create shaders and effects without writing a single line of code. And last but not least, I'm really excited to announce today, for the first time, that in the 2019.1 version of the Unity editor, that the Magic Leap and Lumen Runtime OS are becoming a target build platform directly in mainline Unity. And with that, we have a little bit of time for Q&A, but thank you guys a lot for coming. If you do have any questions, please line up on the mics in the aisleways here.
Thank you.
Thanks a lot. You have a question?
Yes. So we've already used your solution for scaling up the camera perspective. That way you can sort of physics of things that you want to be made small. And we found that it works great when we make builds, but as soon as we scale up the camera perspective past about 6 times, the camera just fails to update for zero iteration. And so I was wondering if this is a bug that you've experienced or if it's just something special or strange going on in our project.
So you're saying like you had issues with scaling in zero iteration, right? Yes. Sorry, go ahead.
Oh, just speaking of exclusively when playing in the editor using zero iteration. The effect works perfectly when we make builds to the device.
Yeah, so we know about that bug actually, and we are fixing that very soon. Yes, definitely.
Over here.
Okay, so when the HoloLens and UWP became part of mainline Unity, one of the issues we faced was every time there was a new release, there would be new breaks, and this went on for about 8 to 9 months. How can you ensure that this doesn't happen with the Magic Leap stuff?
So something we're doing with Unity in general is we're actually upping a lot of the QA processes that we're doing as we're moving over to things like packages. And then we're supporting what we call LTS versions of Unity, which are long-term supported versions that end at the end of every year. So right now there's an available version of 2017.4, which is the LTS version, and I would also expect an available version for 2018. So I guess besides that, while the main line is coming in 2019, we've definitely been ramping up our QA in general. So it's something we're hoping to avoid in the future. Yep. Over here.
So our app is voice activated using Watson. Whenever we're listening for user input, we're getting this red microphone icon hanging out on the scene. There's any way to change how that looks or remove that? And also, is there any way to change the interface that users have to go through when allowing permissions for microphone camera access?
Yeah, so with respect to the icon, yeah, there's been a few people who have reported that, but I would encourage you to put that comment or question on the developer forums that we have. We will definitely take a look at that. With respect to the privileges, you're right. A lot of people are running into that, and we are realizing that. So in the future iterations, we are improving the UI by like partitioning the list of checkboxes into sections for sensitive, non-sensitive, and reality, plus making it easier for people to understand what privilege is required for what feature. And also we are looking, this is more into a future iterations like sometime in 2019.1. We are trying to see if we can auto-enable the privileges, but still it's still in works. So,
Hey, I have questions. First one, is there a way to delete the persistent points?
sorry, could you?
Is there a way to delete the persistent points after they're created? I just saw the creation process. So once you create a persistent point, how do you then remove it? Is it just as simple as going?
Yeah, so you can delete the persistent point. It's a delete binding method that you can use. And the PCFs, one thing I want to just clarify is the PCFs are what the platform provides. And the app has no control over which PCFs are identified. They are generated by the platform. All you do is just associate your content.
You can get to that binding, like identify which specific PCF instead of just.
By default, the ML persistent point uses the closest PCF and creates it. But like I said, the source code for the ML persistent point is exposed to you. So if that doesn't work for you for some reason, you want to specifically associate with a specific PCF, you can change the code to suit your Sorry, I
If
didn't.
you're looking for hand tracking, are you guys looking at improving that?
With the hand tracking, what part?
Because at the moment, it really works in this zone. At least that's what I found. So is there any way of extending that, or is that a hardware limitation?
I'm not entirely sure at the moment, but like I said, definitely posted on the developer forum, and our dev will be able to answer.
Okay, thank you.
Over here.
I was worried if you have any best practices for transitioning from the floor to the walls or ceilings.
So the question was around best practices for transitioning from like the floor to the walls or ceilings, stuff like that. Unfortunately, with using the navigation system, you have to create those off-mesh links at runtime. It is possible, but a little bit more complicated. The other solution, and actually what Drive does by default, is actually these links in and looks at the normal of the spatialized mapper, so that as you create these links or this mesh between them, you can just take advantage of that. So you could kind of hard code it where you're jumping between those based on like the normal values of the edges there.
And another one is, do you have any idea of how you would track a hand rotation? Say you have to think of the object as a hand, you want to take in the hand's rotation, is that possible?
So right now, it's as far as I know, it's not exposed in the API. But what you can do is you can potentially link into known or recognized gestures, and then use some things like that. So if you were to pick up an object like this, you would know that your hand was kind of downward facing, and then as it grabbed, it went to a fist, and then extrapolate from that some interesting use cases and stuff.
Okay, thank you.
Yep.
Questions? What is there's rainbow effects? Yes, no, any suggestions on how to overcome that?
Can you speak into that mic?
Yeah.
Okay, so the rainbow effects, when we see this through the lenses, they have like a rainbow kind of a tint, kind of over made up everything that you see, right? Is there a solution or any suggestions to kind of overcome that?
You're talking about integrating like post-processing or post-effects?
Yeah, something, yeah, like that could be, or maybe just the limitation of the current display, and kind of wait for the next gen or something like that.
Yeah, I mean, certain post effects should kind of work by default, but you're obviously going to get a little bit of an overhead. And the one thing to keep in mind is that they're going to appear in the entire kind of camera view. They're not going to go to specific objects. But yeah.
It does get pretty bad when you have like a large object and kind of solid colors throughout. There's like brighter colors and it adds more to that.
Yeah, I'm not sure specifically right now, but if you want to reach out to me via email, you can do that, and we can maybe discuss this a little more.
And the second question is, so there seems to be like a little bit of color mismatch when you switch from the near photo to the the far photo kind of. And there's a little bit like discussion going on more, but not a solution for that.
Yeah. So currently, yes, you can notice a bit of a difference, but it depends on the display calibration. So if it is too jarring, maybe you can reach out to our developer support. They can help you out.
So you're saying that's not supposed to happen?
Sorry?
You're saying that it's not supposed to happen?
There is a subtle change that you might see, but if it is too noticeable, it's too jarring, then yeah, there might be some display calibration that can be able to fix that.
Okay, alright, thank you.
All right.
Over here.
So this is kind of a two-part question. The first part being, is there ever going to be any future support for two Magic Leap users in the same space to recognize that they are in the same space? And the second part would be, would then they be able to transfer PCS between each other?
Yeah, that's a great question because that's going to be our big focus in the future iterations. We are already working on some solutions. It's a bit too early to say when it's going to be available, but we are that's our big focus right now. So yeah, you should be able to share PCFs. You should be able to have shared experiences.
So that's definitely looking into the future.
Definitely. Yes.
Thank you.
I love Unity, yes, this is awesome. I have one question. What does it mean for the developer to be live in 2019.1, to be part of the core engine and the core engine integration?
Yeah, I mean, basically, right now, if you're developing for Magic Leap on Unity, you're using a special developer preview, and that has to get forked off in a certain version of Unity. If you're live in the main engine with 2019.1, it allows you to get all the optimizations, all the new features, all the new functionality that work within Unity for applications on other platforms and bring them into Magic Leap. So really it opens you up to a lot more possibilities of what you can build, as well as support and things like that, where our QA team doesn't have to go and grab the special version and all this. It's just something that works in the main line.
Thank you guys so much for the talk.
Yep. And I guess we have time for one more question here. And we'll be around after if you guys have any more.
Is there a way to associate that content to a PCF without persisting the binding? So to basically anchor the content to the world, but not necessarily persist it through multiple launches of that?
Yeah, I mean, the whole point of PCFs is enabling persistence, so the saving is kind of important. But if you look at the implementation of ML persistent point, you can see that it uses the ML persistent point, ML persistence API underneath, and you can see how it's interacted. So the way it's designed is you can choose not to save the binding, or you can also choose to save it in a different format than we are. So you have all the tools to completely customize it for your need.
I guess the question is, I want to make sure the content is stabilized to that specific point in the world, and I want it to be kind of associated to a PCF so that it's the most stable. Is that handled underneath the...
Right, yeah, the stability of the PCF is determined by the perception there.
Okay.
But if for some reason, you can potentially, so if you want to really make sure that your app can come back when you reboot the app, is you can associate it with multiple PCFs. So if one PCF doesn't exist, the other PCF might be there, and you might be able to associate it with that and restore your content with that. So you can improve the resilience a little more if the PCFs are a bit finicky and not reliable.
Thank you.
Sure.
Thanks a lot.
Thank you, everyone.